ready?
Fly.
Switching now. We ready?
All right. Okay.
Thank you all for coming. We are Team DMI, or the City of Palo Alto, and we're doing our final practical presentation on our survivable social network. I'm Ryan. This is Yona and Stu. This is our team members right here. So what we're going to talk about today is all these things right here. So we came in 3.5 months ago, roundabout, and we were given this problem and an idea of a solution, and we were told to run with it, which is what we did. So we're going to talk about that problem. We're going to talk about that idea. We're going to go into what we did to implement these ideas. Our field trials, we got a chance to deploy twice over the semester. What we found at those and where we think this work is going to go in the future. So first off, what's a disaster? A disaster is a sudden event that causes great damage or loss of life. This can be a range of anything, from car accident to natural disasters such as Superstorm Sandy. So what we want to do is we want to limit this to something similar to a mass casualty incident. So this is any incident in which services, personnel, and equipment are overwhelmed by the number and severity of the casualties. So when we talk about disaster, we're talking more to that area. So disaster communications. In 1989, there was the Loma Prieta earthquake. This was a huge disaster, and the fact that it completely dropped the communications infrastructure. 154 out of 160 telephone central offices were dropped, and a lot of them lost power and subsequently lost backup power as well. The interesting part about this was this system was designed to withstand an earthquake, yet it still failed. So that was 23 years ago. You would think today that we'd have something a little bit better. But as we can see now, we're more reliant on communications than ever. More reliant on data communications, voice communications. The current cell towers that we have now are not designed to be as robust as those wired systems once were. And there's no adequate redundant system available if those cell towers go down, if that wired telephone communication goes down. So we have two problems. The first one is the communications infrastructure is not resilient. It's based on power, it's based on battery backup. So once the power goes out, you have maybe 4 to 6 hours of battery backup, and this is not resilient for a large-scale disaster. In addition, we have network congestion. So if there's a large-scale disaster, people are going to want to talk to their family. They want to talk to their friends. They want to make sure everyone's okay. Once you have large numbers of people trying to connect to these antennas, they're going to become congested. People will not be able to connect to them and get out on those mediums. And finally, the hardware is very exposed. You have your cell phone towers outside. You have your telecommunication lines run up and down the streets. These can be hit by tree branches. These can be blown over by large, powerful wind gusts. It's just not very resilient in that fact. The second problem is there are inefficient communications. The traditional disaster communications is very centralized. As agencies come in and they start to do their disaster management effects, they become the gatekeepers of this information from the government and the NGOs down to the public. In addition to this one-way flow of information, there's valuable information from witnesses are lost to go back up that chain. So we want to be able to take all this stuff and have a two-way communication system. There's limited coverage when telecommunications is unavailable. When telecommunications go down, people come in with this specialized hardware, this specialized training, this specialized software, such as ham radios and things of this sort. And it's not something that everyone is trained in. It's not something that everyone has access to. It's not something that people use every day, so it can sometimes become a little rusty. And then finally, because all this stuff is out, it's difficult to coordinate response activities between responders. Some of this traditional disaster communications, as we said, ham radio, phone, in-person, sneakernet, etc. All this stuff is one-to-one communication It's not very wide, and it's between responders groups. When you want to get information out to the public, you use broadcast communications such as TV, radio, print media, things of this nature, which once again goes back to that one way. There's no back up, and it's really hard to get back up. So the solution is to use social media. So this is the definition of social media. The thing that we really want to emphasize here is that social media facilitates interactive communication and content exchange, which is what we think are the main drawbacks of this traditional disaster communication. So the benefits are it's highly scalable, it can be widely deployed, and it gets rid of that centralized feeling of you have your agencies coming in and they're the ones controlling the information going out. Now you have that two-way communication, and it gets the public engaged and gets them to present the information they can find. It's inexpensive, requires no training. It's something that we use every day. And it gives us instant feedback. So people can give their feedback on what they think is happening, and agencies can give their feedback on what's actually happening. So Stu, you show us how we can fix this.
So you can sort of see this Venn diagram of problems. On the one side you have brittle, unreliable communications infrastructure. On the other side you have communications problems. So even if you have a social network, well, it's relying on this infrastructure. It turns out at the center of this Venn diagram, there's a solution. This is the survivable social network. And we'll talk about the concept here before we dive into implementation. So the concept is, rather than rely on all this brittle communications technology, you can host it locally, rather than relying on that backhaul provided by larger ISPs that could go down in a mass casualty incident in a long-running crisis. This locally hosted service can provide data communication, it can provide voice communication, the sorts of technology that people use on the larger internet. And it's built using consumer technology, so you're using the internet in the way that you're used to. So you can, block by block, begin to build network communication within a neighborhood. You can provide phone calls and messaging, the ability to keep people connected, share static resources, and of course, as we'll see later with DMI, you can even integrate with emergency responders. The key is keeping everything simple. We're looking to reduce, as Ryan was saying, all the barriers of training and expense as much as possible. So we're relying on technology that already is in a lot of places, things you see in your everyday life. If all this stuff looks familiar, it doesn't look like, you know, disaster-specific software, that is by design. We're using home-grade laptops, home wireless routers, and the smartphones that everybody already has on their person. So there's no cost, well, there's low cost. You don't have to go out and requisition anything in particular. Nobody needs any extra training. It's something that's already integrated into everyone's life. The interface, too, should be just as simple. We want to mimic the systems people are using every day to maximize ease of use for the largest set of users. Anyone should just be able to pick this thing up and use it intuitively, from a toddler to a geriatric. This way, you don't have to worry about specialized training. It just becomes effective instantaneously. This is, as we mentioned with ham radio, a known problem. The setup, too, should be simple. I mean, this is coming from a bunch of Carnegie Mellon trained engineers. You should not have to have a degree from Carnegie Mellon to get this thing working in your home. We'll provide the files open source. So not only is it free, which is, of course, a large benefit, it's customizable. So any community that feels that the template could be extended in one way or another can extend it. They can make their add-ons available and start developing a wider development community. So it's easier for everyone to solve problems and get each of these instances of the survivable social network to do what needs to be done in each individual community. The setup instructions should be as simple as signing up for any of your favorite web-provided services, your Facebooks, your LinkedIns. We're looking for, some HTML forms you fill in. That's going to run scripts that will set up your local site. And also, this is another key, synchronize the organization of your local group through an overarching network. You'll sign up your users on the overarching network, your Facebooks, your LinkedIns, your Twitters, building groups there. The information they already have on there is pulled in automatically to keep the system current. You don't have to send people forms periodically. The information's already there. You can organize by specializations for those with special training or any particular resources or concerns within community, fully customizable and kept up to date automatically. So just another visualization. You have all the information stored in the social network while the overarching network is available. After they're signed up, periodically you ping the social network. It keeps periodically updating the information stored on the local server. That way, when the power goes out and the internet disappears, you're still up to date. Then the information on the laptop goes the other way. It comes out from the wireless router and used to provide already configured services. You'll find your contacts from your neighborhood contacts from the other social networks. You'll find services that are seamless, easy to use. It's like the internet is there, but it's on somebody's local machine. So that's the concept. Here's what we managed to do in implementation.
So we started with a very wide pool of functionality. In the beginning, we had ideas, we had different requirements. Our development showed us that we had to narrow down this functionality and adjust them to the actual needs of the real users. So initially, we considered that phone service would be something very important, especially when telecommunications are down and they're not operable. So we created this functionality where you can actually go ahead and make phone calls, but the experience is going to be very similar to what you experience through your phone. It's not 100% seamless. You need an additional application there, but it provides you the same experience as you have when you use your phone. Then we went ahead and, knowing the power and the popularity of social networks, we went ahead and used our own framework, our own open source social network framework to give the user the opportunity to send messages. These messages could be in an email form, they could be in a private form, and they could also be in the form of statuses. So the status would be, I put a combination of image and text saying, so this is what is going on here. And also they had, through all this support, they have the opportunity now to contact friends, contact neighbors, check how they're doing, and also request for help from emergency response. Additionally, it's really important in this kind of framework, having the resources that are available. The user needs to know where they can find maps, to know where they are and where they can go, know information about where to get food, water, shelter. Of course, contact numbers. Who do I call? How do I call them? How does this change with the new application? How do the numbers change within there? And actually, they don't change. So the numbers remain the same as they are. And finally, ask for help, first aid. Where do I get medical help? So this model has become from a one-way model we turned it into a two-way communication where both citizens can interact with citizens can interact with agencies, and agencies can interact with agencies. So everyone can get involved and provide their feedback in a situation. So the architecture, when we deployed everything, as Stu already said, we went basic. We had a very regular consumer laptop. We used the MacBook Pro. On this laptop, we hosted our web application and also cell-like service for providing the phone functionality. And all the software we use, as you can see here, is free and open source. So VirtualBox is just a virtual machine which is free. ELG is our social network framework, and Asterisk is the OpenPBX through which you can support the phone calls. So the wireless router, it's a very basic. It's this one actually. It's a very basic. Some of you might have in your home. Most of you probably have in your homes. It's a very basic consumer wireless router. It acts as the backbone of your local internet service, and it works as a mini cell tower. we figure out that there are limitations there. So this, for example, has a very small coverage area and it can support few people. But this, we'll talk more about it on our reflection for future work and our findings. And finally, our smartphones. So the benefits of the smartphones is that you can go ahead and use them. The social network application is an HTML5 application. It can be rendered by any laptop, by any smartphone, without having to download any application. And the benefit of it is that no matter what your device is, no matter what your platform is, you can go ahead. It's device agnostic. So as I said, we had a very big set of functionality in the beginning. We realized on our very first trial that this functionality was becoming confusing. We had way too many click this, do that, make groups, make friends, add friends, send hi to friends, say bye to friends. So we decided that we need to provide them a core set of functionality where that is very intuitive to go ahead and perform any task without having major difficulties, without trying to minimize the learning curve as much as possible. So we ended up coming with this design having very few 4 functionalities, where it's actual messaging, static resources, email, and your friends. So next, Ryan is talking to you about the field trials and what happened there.
So like I said before, we had the opportunity to do 2 deployments and 2 field trials. The first one we did was at Quakeville. Quakeville is a disaster preparedness event run by the city of Palo Alto. It's a bunch of disaster management community to come together and do a practice run and to give ideas on how things would be run in the event of earthquake. So we had our first 3 to 4 weeks of a rapid prototype. As Yona said before, it was very confusing, very convoluted, but it was something, and we went there and pitched the idea to this community to gauge their reaction and see what they liked, what they didn't like, to refine our requirements and come up with a better system that would be used. So we observed users interacting with the system. We talked to them, they talked to us, they asked us questions, and overall it was a very, the feedback we got was very positive. They liked the idea, they liked the fact that we're using smartphones, things that people already have. But like Yona said, there were some things that we needed to change. So our next deployment was at the Disaster Management Initiative here at CMUSC. So we went back to our cave after Quakeville, and we came back and took all of the feedback that we received and integrated it into the second version. We narrowed it down to those core functionalities that we talked about, and we added this interoperability functionality so we can talk to other systems that were being used at the DMI. These systems include the Hyperwall and the Palo Alto MIAC. So what we could do there is we could send geolocation, we could send images and messages up and down the system from a user on a cell phone to the Hyperwall, to the MIAC, and then back down again. So we could show that concept of citizens interacting with emergency services and emergency services interacting with citizens and that communication between the two. So let's talk about our findings.
We were fortunate, as Ryan mentioned, to have a couple deployments, and that sort of helped us think iteratively. We had 2 very different sets of goals. Starting off, just get it out into the world. Get something out there, you have a few weeks, we need something for feedback, versus you have a thing that exists, now can we integrate it into a wider system? So you can see our field trials. Here's sort of what we found from the results and how that's affected our thinking on, between iterations and where we should go from here. So Quakeville, content verification was a big deal. That came up a few times. The power we're leveraging here is the ability for anyone to become a stakeholder in disaster management, communications, interactions. Of course, all these people are untrained. How do you filter? The common metaphor we kept hearing was 100 pictures of a dead cat. So we came back thinking about that heading into DMI. Also, as Yona mentioned, this is really where we started to see the necessity of what Bob began calling a dead simple design. The need to make it so anyone can pick it up and use it. We started off, it was very cluttered because we had just picked up the ELG framework, we've got it going, we've got it working, but we used a lot of different plugins that ELG involves. The ELG framework, very easy for anyone to pick up and start. It turns out more difficult to customize, a bit about that later. But we had used a lot of plugins, a lot of lists, very confusing. What we needed to do was make the interface simpler. And it turns out that concept of simplification also had ramifications in the way we coded the application. We started thinking about what can we have as one function, one metaphor that we can sort of adapt into different areas to suit all the different needs we needed to satisfy the requirements for DMI. Rather than sort of a Facebook model where we're dealing with posts, we began thinking more about adapting a Twitter-based small posts model to sort of tie everything together and keep the metaphors similar. So that's the functionality we started thinking about moving into DMI. Of course, taking that initial basic functioning system and integrating it with a larger SVRN, Silicon Valley Resilient Network prototype. Through data visualization on the emergency response side of SSN information, the ability to take SSN community users and gather data from them, and of course add geolocation functionalities as well. What we found in adding all those features to our software, the ELG framework, as I had mentioned, very easy to get up and running, fast to start, but when you start trying to customize and do more sophisticated things, it turns out to be inflexible. You have to learn their way, which is not necessarily, in our opinion, the cleanest, best way to do it. The way they handle model view controller is not super clean. And their official line on their database schema is just don't touch it, just don't touch it. Use our, they do sort of a, through adding a lot of metadata, they do like a NoSQL through SQL, which as we look forward into NoSQL implementations, this could be, if we don't solve this now and clean it up at this stage, it could impair further development. And of course, it's, as I mentioned, complex, not necessarily intuitive with a lot of clean coding, that sort of thing. And the development community is sort of small, the documentation is not excellent. It just doesn't seem scalable for the size of deployment we would like to see. We mentioned wireless routers also. That was another surprise we had. We were hoping we'd get about 1,000 feet, given range and power. Maybe not with a consumer model, but maybe with the sort of wireless routers, wireless antennas you see around campus. If we got them high enough, maybe everything would be fine. We found out we got maybe 300 feet, which isn't great. So looking forward, we talked with Professor Tague about mesh networking, ways we could get all these wireless routers that are in everybody's houses to talk to each other, start looking at building a block, building a community network, building a city network that way. And of course, there are other maybe edge solutions about getting more more footprint easily with getting your wireless router up in the air. So those are some things we're thinking about moving into the future for the next step of the Survivable Social Network. For more on other overarching issues to resolve, here's Yona again.
So from all our findings and all the field trials, we came up with things that we didn't manage to do, didn't manage to finish, and things that we think would make the software and the package more useful to the entire society. So first of all, we started working on integrating our setup and maintenance with social networks, Facebook, so that it stays up to date. So here we started the setup process and the integration. The integration stayed halfway because then we shifted our interest towards geolocation and other information. So we're really looking forward into our successors coming and completing this functionality and providing a very interactive way where information can stay up to date. So our other vision for this project is that in the future it needs to be easily installed. We need to have this packaged software where the installation process is as simple as anything. Maybe a push button and the installation process goes on its own. It's already pre-configured. You don't need to set up anything. Then, as Stu already said, mesh networking would be a great opportunity for this project to get expanded. So at the moment, we're already covering a very small area, and we would like smaller, maybe not communities, but smaller neighborhoods start to connect with each other, interconnect, and start building this mesh where gradually everyone, a bigger area can be covered. So we also talked for replicating hierarchies. So by replicating the organizational hierarchies of the response teams within our application, we can actually help control the information of the flow information, the information flow. So not everything, for example, the dead cat, it doesn't need to reach the National Guard. It probably is just going to stay down there. Nobody's going to figure out about it. So, and also based on the functionality and the training they have, different roles can do different things, have different functionality based on their access levels. So even though we worked on ELK and it was a hard time, we admit it was a hard time for us working on ELK, we did realize though that, and it was important to realize this early, that the framework is not as flexible as it should be. So we're hoping that in the future this entire framework is going to be rebuilt in more flexible design with a better architecture, where the developer will have a very lower learning curve and start adding value to the social network and the other infrastructure much faster. So this way you can, by shifting from the small community of ELK, you can actually leverage large benefits from larger communities with much more knowledge and more flexible design. I would dare to say maybe a more right design for the kind of flexibility we require, for the kind of for the amount of people we need to cover and the situations that is going to be deployed to. So finally, we're looking forward to our successors actually deploying it not in real disaster. I'm not looking forward for a real disaster, but deploying it in the public publicly and integrating the whole infrastructure there with the Palo Alto CERT training. So this way you can keep track of the training levels everyone has, how often do you need to train them, to retrain them, and also provide service in event of an emergency. So during the course of the semester, we did several presentations for this, and people showed a lot of interest, a lot of volunteering interest. So during Quakeville, we have different cities around the Bay Area being interested in adopting this model. We received a lot of interest during BRMA from both individuals and businesses, which was, we were surprised actually. They were looking forward to download this application both for their homes in their neighborhood so that they can support people around them, but for their businesses so that in case of a disaster they can have their data accessible. It was very interesting for us finding that. So with that said, the other we're looking also forward to having a bigger community developing this software. We're planning to have it an open source software, free open source software though. So the more people that can join in this initiative, the more functionality and the more benefit is going to be for the wide society. So with all this said, of course we'd like to thank you all for the support, not just Bob for guiding us and supporting us throughout the process, but all of you as you have been there throughout all our stages. So you can all see your names there, and Sam's mom and dad. So questions?
So I tried to log in and send a message, and I discovered a few little glitches. Are you going to be demoing, or?
We can if you'd like. We have all the stuff here. Yeah, we weren't expecting to be on Adobe Connect, but we can show just a brief demo right here. So, why not? So these are the main functions of our system. We have a consumer laptop, wireless router, and smartphones. The wireless router will act as the DHCP server. The consumer laptop will be a DNS server, as well as the web application and the VoIP service. So once you have a disaster come on, you can hook this up to your battery power. This router is power over Ethernet, so you can have that option if you needed to. Hook up your cell phones to your Prius, charge up those, and then you just go into your settings and connect to this wireless access point. Once you do that, you have the opportunity to log in. If you've already logged in before, you already have your username, password, things, you were a very good person and you decided to be proactive. Or you can join then. This still has the joining option. And go on, you can make friends in there if they're not already there. You can use your VoIP service to make phone calls to your neighbors, anyone connected on the same network that you are. And we also have experience with establishing a trunk network through a satellite connection. So you can actually get phone calls out via that satellite connection as well. So it's not only within your network, but you can also get outside the network as well, which is extremely important. As you've seen before, I don't know if you can see this, it's kind of far, but it's a very simple model. We have 4 main functionalities. There we go. So we have 4 main functionalities. We have a wall-like system where you can put your posts, your tweets, whatever you want to call them. It can be text, it can be images. We have static information. So this is the maps, this is the first aid information, where to get, so it's this one. We have email messages, which is pretty much just like a one-to-one or one-to-many private message between you and your groups, just like messages on Facebook or just email. And then you can see your friends. So you can see those in your neighborhood, those you're connected to. You can create new friends, those you're connected to, and so on and so forth. So basically through these 4 main functionalities, we feel like that's the best way for the system to be very compact and for users to use it and get the most that they need out of disaster. You guys have anything to add?
So I just maybe one thing we should have in our presentation. So we have this small filtering here where you can filter, information, show what everyone has put there, show just mine, show just friends. So this is the very beginning of maybe a machine learning model where you can filter data based on, we're discussing it on hashtags. So hashtags will be put in there, and on the server background algorithm could figure out what's being brought up many times. So then it can get promoted in some automatic way, so that you don't have people depending information being tied to people necessarily. So anything else?
We can also use, you'll see even this grouping of friends whose friends are there. This is everybody. You can also use, the ELG model provides a grouping structure that could provide a basis for hierarchical showing control of information. So depending on where you are within an organization, you'll see certain messages, you won't see others. A way to, again, prevent the wrong people from waving off messages of dead cats.
So where is the picture of the baby?
We had the dinosaur, so.
Yeah, we ended up having that was actually an important
Yeah.
one, I think. He was wrecking Mountain Dew. We ended up cleaning everything off before DMI, but we had all sorts of interesting stuff on there as we moved through the development process.
Well, I'll just have one comment on behalf of the City College. I want to thank you guys for being so excellent to work with, and it's very impressive the amount of development that you did and the amount of learning that you obviously derived from it, more importantly. So on behalf of the city, thank you very much.
It was our pleasure.
Yeah, thanks for the opportunity to, work on a good novel idea that seems to have traction and could really provide service not just for the city of Palo Alto, but could be sort of a boon to wider humanity.
Absolutely.
Thanks, Ken, for your sponsorship.
Yeah, absolutely, Ken, it was outstanding sponsorship. Any other questions?
So did the team use, excuse me, an engineering notebook? And if you did, how effective did you find it?
We had a lot of trade-offs. I mean, I think you can sort of get a sense, only a little bit from the presentation, all the things we had to decide between. Is ELG really the best way to go was probably the first major decision we had to have. After looking through, we decided to go with it. After this development experience, you know, we still have Ruby on Rails right underneath it. And that, as you know, ended up being a direction we really hope the project moves in. From there,
We had a lot of trade-off on functionality. So as we said, on our very first deployment, we had a lot of functionality. We had to decide what we're keeping there, and we came down to these four very core elements. The other thing on our engineering notebook was during right before DMI, we were having several technical issues. We had to decide what was the path. So, for example, very close to DMI, we had functionality of images not really working, and we tried to come up with different options there. And one of our worst option was going and just having the URL bringing up the image. But eventually, we had the functionality go till the end the way we initially designed it. So we came up with backup options, and thankfully we didn't have to use them.
Probably should mention that back in the days when I was doing engineering, and I actually had a physical engineering notebook, spiral bound with the signature lines and all that stuff, that's kind of given way to other things in the engineering process that you used, and I know you used Assembler.
Yes, we use
Assembler.
Assembler.
Yeah.
To support all that
And
stuff.
you also use Twiki very extensively for the punch list and
Yes.
tracking issues and responsibility. And
Yeah.
that was great within our team and within the wider set of DMI teams too. I don't know really how we could have done it without all that, keeping that information transparent.
Yeah, so I was gonna say that we did a very rapid prototype. It's not like we had a lot of time to decide between functionalities.
Yeah.
It was,
Our first deliverable was 3 weeks after we
yeah,
started.
so we had, you know, 2 options, and then it was go with your gut and choose the one that you think is gonna be the right choice and just go with it. That was the majority of our talks with Bob and with Ken, and to see where we wanted this project to go.
And it's not necessarily, we didn't necessarily take the best decision in some cases. There were nights that we stayed up till 5 in the morning just to figure out why did we make this decision. But, and I think ELG gave us a quite hard time with the learning curve. It had a quite high learning curve. So, yeah.
Right. So open
We
source.
bash ELG a lot, but really,
Yeah.
that was a big reason we could
It-
have
it
the
gave
showing we
us-
had at Quakeville, which was really the first deployment. You know, there was a lot good came of it, and I think we have, I mean, we got it to work. We got our deliverables at DMI, but I think we would all like to see something that has the capacity to be much cleaner.
Yeah, I mean, certainly the observation that open source does not equal good or easy.
No. No.
Well, so it depends. I mean, I've been always working on open source, and I've seen different systems. Depends on how big the community is.
Yeah.
Depends on how long it's been
It has
existing.
to
So,
stabilize, right.
and depends what functionality it serves. So,
So ELG is really good for rapid deployment. It's really good for, you have this core functionality, you want a social network, it will give you those core functionalities, but whenever you try to go and tweak something, that's where we ran into problems. And this is something that hasn't been done before, so it needed a lot of tweaking. So we ran into a lot of problems.
Yeah.
it's great and functional for a person that is not trying to do any technical work with it.
Extremely easy.
Extremely easy. Go and play with it. But if you want to go on the background and do technical work, development of new functionality, it's hard sticking with their architecture. They have a
takes
very
like-
flexible architecture.
It takes like 15-20 minutes to get their base functionality up and running. So,
In the midst of development, Ryan and Stu both found themselves on the East Coast when Sandy hit. Ryan got
Yeah.
back, but Stu was stuck in New York until Friday.
Mm.
And maybe you have some reflections on the potential relevance of SSN in disasters like Sandy from firsthand experience.
Yeah, I was in the position of sitting, I think it was Wednesday night, was the height of the storm coming through New York. I had the great good fortune of my neighborhood being spared. I was able to have power and internet the whole time, which meant I was listening to the radio, hearing about how the rest of the 5 boroughs in New Jersey and Connecticut were faring, while I was coding this project the week before DMI.
Yeah.
That really put everything into perspective. Sitting there in my apartment in Brooklyn, where you could see this giant list of wireless access points that you could just hop onto. Was there some way we could get that out into the Lower East Side where it was dark? No phone, nothing. And all these people with their cell phones. Also, another thing, I remember hearing this the next morning on the radio, where they're saying, what we need to do is get people to call 311 instead of 911 for downed trees. You're clogging up the network. I mean, they didn't say it that way, but that's what they were doing. You know, denial of service attack from these people trying to help the community. I'm sitting here like, well, we have visualization tools. You know, join up, put it on the map. You know, you hit the tree button, you filter for downed trees, you can figure out a path. You can figure out how to get where you're going. So it was good that you could see how practical it was. It was sad because, I mean, I've even had people come up to me afterwards and say, so did you get to deploy? Well, we're working on it. We're working on it. There's much work to do, but I think it really made the practicality of this project extremely real.
Yeah, amazing timing.
And of course, after that Wednesday night, on a Thursday night, we were looking for him to fix something. And we couldn't find him through his cell phone, so we found him on SSN.
Yeah, that's
Where he
true.
was
We were
luckily
able to
showing
reach
it to
him.
someone else, so he saw it and he jumped on the line.
That's, I forgot about that.
Yeah.
That's true. We only were able to race in the
Yeah,
SSN.
I
and
sent
all
2
of it.
emails, Bob sent another one, Ryan started texting, but we
So in
just
that
wanted the rest
sense,
to
it has
send.
already been deployed for disaster
It was
management.
deployed in Sandy and it worked.
Then we, you know, built a post and Stu came back on and replied to it. He's like, I can see everything fine.
So you guys did a fabulous job, and I really
Thank
want
you.
to say
It was
from
great
the bottom
working
of my
with all
heart,
of you.
thank you. You made this a fun project, and you learned so much more than I could have dreamt.
We're excited for where he's going,
I
Yeah.
think that it's, and,
especially after our
We
conversation.
definitely have to keep it together.
absolutely, and Ken, as an outstanding sponsor, City of Palo Alto.
Don't worry, we'll have more disasters.
We're scheduling
We're
it
not
on
looking
Wednesday.
for
Excellent.
Maybe no fire-breathing dinosaurs. But
Yeah.
actually, it
You
rained.
never know.
It almost rained hard enough this weekend.
It was pretty
Yeah.
impressive.
Yeah,
this
sure.
weekend.
Flash flood.
Okay, so thank you guys, you did.
I'd like to take a team photo.